Okay, so 1.7 was about inverse functions. It says in 1.7, graph each function, and then applying the horizontal line test to determine whether the inverse of the function exists. So I'm going to be your graphing calculator, but if you weren't going to put these into Desmos, this one here is a v that's up 6, okay? So because of that, it fails the horizontal line test anytime it's an absolute value function, the standard absolute value function. So that would be a no. Number 54. If you were to look at our parent cube function, it looks kind of like that. And it passes the horizontal line test. Horizontal lines will only ever touch it once. So that's a yes. 55. 55 looks something like this. It's kind of been moved to the left, flipped over, our reciprocal function. So it looks, again, something like this. Okay. And if we were to hit it with horizontal lines, it only ever hits it once. So that's a yes. 56, if you were to graph it in Desmos, although it's a cube, if you were to look at the graph, there are some bumps in it. This, again, very rough estimate. Looks something like that. And you can see here that as soon as we introduced that extra little term, that negative 4x squared, the bumps go up and then back down again in such a way that the horizontal line will hit it more than one location. So that on the chapter test, when we take the chapter test, I will actually physically give you maybe 2 or 3 graphs and say which one of these has an inverse, and that's it, okay? Now, for 57 through 60, it says to find the inverse. Now, I'm going to only focus on 58 and 59 at this time. So let's take a look at 58, okay? To find the inverse of a function, you first put it in y notation. All that means is if it says f of x or g of x or h of x or m of x or whatever of x, just take that out and replace it with a y. So that's your first step. After you've done that, you are going to flip-flop the x and y. That's what an inverse does. The x becomes a y and the y becomes an x. So just flip-flop. So x equals negative 4y plus 8. And then once you have flip-flopped, all we want to do is isolate the y term and solve it for y. So we just needed to read y equals all the other junk. So we are going to subtract 8. We get x minus 8 equals negative 4y. Okay. And then we have to divide by negative 4. So technically our answer is x minus 8 over negative 4. You shouldn't really leave a negative in the denominator, so I'm going to do a little thing that happens. If I put the negative to the top, it actually switches the subtraction. So it would be 8 minus x over 4. If you left it here, you're getting 100%. You've done it, but I'm just showing you. It is not customary. You shouldn't mathematically leave a negative in your denominator. So it actually, if you multiply the top by negative 1, it switches the subtraction, which is kind of interesting. And then you just write it as an inverse. The inverse notation just puts a negative 1, since they called it g. we just say G with a little -1 notation. That just means, hey, I found the inverse. And then we write it. And that is your answer. Okay, so let's go over the steps one more time. You write it in Y notation. You flip-flop the X's and Y's. You solve for Y, and that's your inverse. Okay, again, if you got it to this point, you got it. Okay, so but that's your answer. So I'll probably give you one that is a linear function on the test, okay? So that's 58. Any questions there? Are we good with 58? Okay, let's do it again for 59, okay? So we're going to make it Y notation. We're going to flip-flop the notation of the X and the Y. So now it's going to be X equals 2 square root of Y plus 3. We still have to isolate and solve for Y. So to solve an equation with a square root in it that contains the variable we're interested in, we need to isolate that thing so we can square both sides. So let's divide off the 2. So we get X over 2 equals the square root of Y plus 3. And the reason we do that is so the square roots alone, so we can square both sides. Now, when we square a fraction, don't overthink it. Just square the top, square the bottom, nothing fancy. So that's going to be X squared over 4. When you square a square root, the square root pops off, and it's just left with what's inside. And so then to get that solved for Y, we just have to subtract 3. And so we get that Y equals X squared over 4 minus off the 3. And that's it. You found the inverse. Now this time they called it H, so to put it in correct inverse notation, just put an H with a little -1 next to it. It's not a power, it's just an inverse. This is one that has a restriction on the domain. I want to tell you what the restriction is, but on the quiz, that'll probably, or on the test, that'll probably be like a little bonus piece of information. But if we were to draw this graph, hopefully you know that if you add on the inside, it's going to move it left. So if we look at this graph, it's gone to the left 3 and then swoops over. Okay. The range of that graph, so the Y values used on that graph, will have to be the new domain. The range becomes the new domain. The Y's become the X's on our function. So the domain of this one, well, that we don't care about the domain. The range of this one is from 0 up to a height of infinity, right? The lowest is 0. I'm going to keep going up higher and higher and higher eventually. It takes a while for a square root, but it's going to get higher and higher. And so the domain of this is the same as the range of the other. Now, normally a square has a domain of all real numbers, but think about what we know about that graph. That's a parabola. Does it pass the horizontal line test? Nope. But if we chop it in half, it does. So what this does is it only uses one arm of the parabola. It chops it in half. And so that's why if it says state any restriction on the domain, if you end up with something that is not invertible, like this one is not invertible, then you have to, in this case, like if it's a square root, you would have to chop it in half. If it's a square, you have to chop it in half. So that is just a little extra, little bonus piece of information. Okay? Okay, so that's 1-7. So now if we could skip all the way to where it says the practice test. Now, I don't know how much of this we're going to get done today, but I would like to just, do what we can do, and then you'll turn this in, okay? Okay, so number 1, 2, and 3 says determine whether the given relation represents y as a function of x. So you're just asking, does it pass the horizontal line test? So this one's a yes. Because of this power on the y, it's a no. And then 3, I believe, let me tell you what the graph is, but I think it has these two little arms, almost like a, I think it's like a, it almost looks like it, when you were a little kid and you drew a bird and it has a little, oh, yeah. It kind of looks like a little bird, I think, but I don't want to tell you until I check. So I'm checking in Decimus for you. So if you put in y equals the square root of x squared plus 3. Well, I mean, it kind of does that, but not completely. I think if it was a minus 3, there's a little separation, so it looks more like a bird. But it kind of has this weird little, almost an absolute value, almost a parabola, this weird little shape to it. And so if you were to draw the graph, it would be a no. So the ones I'm most concerned about is, can you look at a graph and say whether or not it has an inverse, okay? So that's what I'm focusing on, okay? Let's take a look at number 5 and 6. 5 and 6 says to state the domain and range from the graph. So like I might give you two graphs and say, what's the domain, what's the range, does it have an inverse? So you might be having to look at multiple graphs and giving me multiple things, okay? So let's start with the domain for each. Remember, the domain goes from left to right. It is the set of x's, okay? So always remember, domain goes from left to right. It's a set of x's. This function goes to the left as far as we want, to the right as far as we want. And if our little math bug is walking along, he can go to the left and the right wherever he wants. So the domain for that is all real numbers. Let's talk about the domain for 6. There was a very important creature just walked past. He went away so fast. He must have went in a classroom. Okay, anyway, so for this one, I can get as left as far as I want. So the domain starts, my little math bug can go to the left as far as he wants. That's the negative infinity. But if we think about if my little math bug is walking, he is going to have to stop at that particular x value. Well, let's just, they're counting by 2s, let's just call it 5. And there's not an open circle, so let's assume he can actually stand at 5. If there was a definitive open circle there, make sure to put a parenthesis. Okay, so those are domains. Let's talk about range. The range goes from the bottom of the graph to the top of the graph. Those are the y's. Okay. Start at the bottom of the graph. How low does this graph get? How high does this graph get? The low point of this graph appears to be -3. And then this graph can go up as high as I want to infinity. So that's how you write it. I can go at -3. I can go up to infinity. Okay. Let's take a look at 6. What's the lowest height that I can go to? What's the lowest height I can go to for 6? 0. I can stand there because, again, that it appears to be a dot, a point. How high can I go? Yeah, I can keep going high as I want. So that's infinity. So make sure that you understand how to draw the graphs from negative infinity to positive infinity, domains, ranges, is it a function or not? these are both functions, but this one does not have an inverse. This one does. Okay. So if they would ask you that. Let's practice finding y-intercepts and zeros. I think that's a skill that practice would be helpful. The y-intercept, we're letting x equals 0. The zeros are the x-intercepts, so we're letting y equals 0, or f of x equals 0, however you want to think about it. They both mean the same thing. Okay. The y-intercepts are the easy ones, so let's do those rather quickly. You just plug in zeros, see what you get. This one you get negative 12. This one you get 0. Okay, so I love y-intercepts. They're just so nice. You plug in 0, what do you get? Bam, you're done. Okay, so that's good. The one that is more difficult are our zeros. Remember, we're going to set the function. Write down the function, set it equal to 0. Write down the function, set it equal to 0. Okay, so that's how we set up the zeros. But then it's really important to figure out, well, what do you do once you set it equal to 0? So let's start our 4x squared minus 8x minus 12. To solve that, you want to factor it most of the time. Okay, so let's take out a 4. Because if you can factor out a common factor, it makes your numbers smaller and littler and nicer. So if I take out a 4, I'm left with 8x squared minus 2x minus 3. Now, you know you're right. I'm sorry, there's a puppy. He keeps evading me. I had to say hello. Is this Odin? Odin. I'm really supposed to be teaching. Hi, how are you? How's it going? I have to.
Is that a magical pen?
Oh, it is. I can write on there. Do you want to? Here, come here. Make one little thing. I'm teaching though, and I'm actually recording this, but that's okay. To make a heart. Make something pretty.
This is nice.
Thank you.
Thank you.
You're welcome. The little girl made us a heart. Okay. So, does anybody remember how to factor that? Anybody remember how to factor that? So, we're going to use the factors of 3 that have a difference of 2. And so that's the nice one where we go x minus 3 and x plus 1. 3 times 1 is 3. 3 minus 1 is 2. We want the larger number to match the middle. So when the back is negative, 1 is positive, 1 is negative, and you want the larger number to match the sign of the little one. That's a good way to remember it, okay? Now we're not done until we set each piece equal to 0. So the reason I didn't set 4 equal to 0 is because 4 is not going to be equal to 0. Now, if there's an x with it, sure, but 4 can't equal 0 last I checked. So we get x equals 3 and x equals negative 1. If we were to graph that, we would have this graph hits the x-axis in 2 spots, 3 and negative 1. So like if you were to graph it, it has x-intercepts of 3 and negative 1, and it hits the y-axis all the way down at negative 12. Looks something like that, okay? So that is 7. Now let's talk about how we factor 8. Everybody good with the factorization for 7? Okay, let's go to 8. Again, you always check for a greatest common factor. They all have x's. The lowest is an x to the first, so take it out. Now that means all the powers go down by 1. So that would be x squared plus 4x plus 3, which is a factorable quantity. Now, when it's pluses inside, it's a little nicer because they're both pluses. And the middle sign just repeats in both. So it's just plus, plus, plus means plus, plus. And then 3, again, is really nice. 3 times 1 is 3. 3 plus 1 is 4. So it's just 3 and 1. And this time we have 3 values. X equals 0. X plus 3 equals 0. X plus 1 equals 0. See how this one had an X in the front. So you have to include it because X equals 0 is a legitimate answer. Now, it has 3 zeros. There's a relationship we'll talk about more, I think, in the next chapter that says that cube there, because it's a third power, it's no coincidence that there's 3 spots that it hits. If you were to graph this function, it goes something like this. It's something like that. It hits the x-axis in 3 spots, -3, -1, and 0. It hits the y-axis at 0. So that's kind of what the graph looks like for that one. So I will not give you any that factor funky. They'll come out nicely. You can always use the, what is it called? The quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. You're welcome to use that formula if you forget how to factor. That will always solve a quadratic for you. Okay, let's move our little heart up here. Here, let's make it red. Okay, so now let's talk about 9. It says which relation is symmetric with respect to the x-axis. I don't want to do that. We didn't do x-axis symmetry. We'll talk about symmetry later, but yeah, we don't care about 9. We don't care about those. Let's jump to 12 and 13. 12 and 13, I'll just do 12. It says find the average rate of change for each function on the interval, okay, from -2 to 6. Those are x's. They're both x's. I am starting at an x value of -2. I am stopping at an x value of 6. So this is x1 and this is x2. So it's very important to know that is not a point. That is an x interval. My function, what is it doing at -2? What is it doing at 6? Okay, so let's plug in -2. Let's plug in 6. Okay, if you plug in -2, you get -8 minus 6, or -14. If you plug in 6, what is 6 to the 4th? You get -1296 plus 18, which is -1278. Okay? Now, let me remind you the average rate of change formula. It's just the slope. You can write it as y2 minus y1 over x2 minus x1. But with function notation, it would be f of x2 minus f of x1 over x2 minus x1. But it is just the function value with x2, which is its y, minus the function value with x1, which is just its y, over x2 minus x1. So we have the function value with 6. The function value with 6 is -1278. We're going to minus the function value with -2. And then it's 6 minus -2. Now, if you just wanted to plop that and make that a plus, feel free. That's really -1278 plus 14 over 6 plus 2. Which is -1264 divided by 8, which is -158. So it is just a glorified slope formula on an end point between -2 and 6. If you were to graph that, that is a it's going to kind of look like an M going down. And it's just you connect those 2 points. Well, it's negative, so. Anyway, you connect the 2 points, and then you're really finding the slope that connects those 2 points on the graph. So, because the graph is not aligned, so finding a slope's weird, but it is just the average rate of change between those 2 points. So if you were to connect those 2 points, what's the slope of that line? And it's negative 158. So the one must be much, much higher than the other. Yeah. Okay, so that is average rate of change. So we've done that a few times. We're almost done. Let's talk about increasing and decreasing. We're just going to do 15, just to save time. We'll just do that one. Okay. I'm going to highlight where the function is going downhill from left to right. When it's going downhill, I'm going to put it in green. And when it's going uphill, I'm going to put it in red. Now it says round to the nearest to half a unit. So, let's assume they're counting by ones. Let's assume this here is negative 1.5. There's 0, that's nice. And then that looks like it hits at 1. Well, we don't care about that. This looks like it's positive 1.5. Okay. So remember the word, the y, we use a word, increasing, decreasing, or constant. The x, we use an interval. It's really important to understand the distinction there, okay? So start from the left of your graph, move to the right of my graph. From an x value of negative infinity to an x value of negative 1.5, my y is going downhill, it is decreasing, okay? And then from an x value of negative 1.5 to 0, my y is going uphill. Let's keep going. From an x value of 0 to an x value of 1.5, that's this little section, my y is going downhill. I've always done the exact opposite colors as I've done just now, but so sorry. And then finally, my x from an x value of 1.5 to an x value of forever to infinity. My y will always be going uphill for the rest of its life. Sorry, I did totally switch my colors, but it doesn't matter as long as we're consistent. So downhill, decreasing for these x values, increasing, decreasing, increasing. So that's kind of, and just remember the x is your interval. If I was walking along these x's, I would be going downhill. The y is your word. If I was walking along these x values, I would be going uphill. If I was walking along this, and so forth. Okay? Does that make sense how the increasing and decreasing works? Good? Okay. Now, let's talk about 16. It says, which function is shown in the graph? Now, we know it's an absolute value. They're all absolute values, okay? Let's pinpoint this location. That is the point, -4, -3. I have moved left 4 and down 3. Okay? How do we make a function move to the left 4? Which one of those moved our function to the left 4? F, G, H, or J? Which ones moved left 4? H and J, because of the +4 on the inside, those two have moved left 4. These two are out. Of the two remaining, H and J, which one has gone down 3? H, right? So a subtraction on the outside moves a function down. So our answer is H. That is the only function that has moved to the left 4 and down 3. Now, how do you check? Because if you forget your rules, how do you check? Would you agree that the vertex of that point is -4? So all you got to do is plug -4 into this equation. We better get -3. If we don't, then we picked the wrong one. Okay, so at -4, we get the absolute value of 0 minus 3, or 0 minus 3 is -3. Bam, it comes out to be the point we're expecting. So you can plug in a number, and I would suggest plugging in the vertex. You can really plug in anything, but I would suggest plugging in the vertex. But you can really plug in any point. The only one that's going to match up in the right spot is H. So, and especially for the vertex. Everybody good with that? Makes sense, kind of, maybe? Okay. Let's look at 17 and 18. 17 and 18 says, identify the parent function, sketch the graph of the new function. Our parent function for this one is r cubed. It's got a cube there. Hopefully you identify that it's going to be a flip, and it's going to move left 3. Okay? So all we got to do is take our normal, move this center to the left 3, and flip it upside down. So if we go to left 3 and flip it upside down, now this down arm's going up, the up arm's going down. So that's what our g function would look like. It would be flipped and move to the left 3. Now feel free, again, you know that x plus 3 equals 0 at -3. So if you're unsure, never to leave it blank, plug in -3, 1 to the left of it, 1 to the right of it. That will always get you, I won't say always, but it gets like 7 of the 8 parent functions. You can plug those 3 points. The center, 1 to the left and 1 to the right, and you always can find what your function is doing. We're not going to do 18. We're going to do 19 and 20. I'm not concerned about the domain at this point. We're just going to find the function. F over g. That is just the f function divided by the g function. That's it. Nothing fancy. So the f function over the g function. Now this is one where technically that is the answer, but you could reduce it because the bottom is a factorable quantity, and it becomes 1 over x plus 6. If you told me that, I'm good with that. Hot speaking. Hey. Yeah. Health for Roberta, just in his room. Not a problem. Okay. Okay, thanks. Bye. Okay, so, but if you gave me this, I'm good. Okay, let's talk about that. That means that we're going to take the g function and put f of x inside of it. Okay, so just take the g function. Remember, this goes into the other one. So I write g, and then I write down what f is. F is x minus 6. So just write x minus 6 right here. And then we're done with f. We know what we're inputting. We're going to input it right here. Okay, so it's going to be that quantity squared minus 36. So just take out that quantity, the x, replace with x minus 6, and there you go. X minus 6 squared, a lot of students mess this up. Remember, x minus 6 squared is x minus 6 times x minus 6. You do have to FOIL it out. So it's very common to mess that up. If you were to FOIL that out, there's 4 terms you get. You get x squared minus 6x plus 36 And then we still have that minus 36 just kind of hanging there. If we were to combine like terms, our final answer would be x squared minus 12x. The 36 is canceled. So that is 20. Are we good there? Okay. We're almost done. 21. It says we've got this Fahrenheit function for Celsius, and we want to write C as a function of F. We're not going to do B, we'll just do A. Okay. So we're going to rearrange this a function solving for C. Okay. So we're going to subtract 32 from both sides so that we get the C term alone. So that's always your first step. And then to get rid of 9/5, make it 5/9. So put it in front of the other side, because technically what you're doing is you are multiplying both sides times that reciprocal. And so our final answer is that C is equal to 5/9 of F minus 32. So if you ever hear a Celsius degree and you wonder what it is in Fahrenheit, use that formula. If you ever hear a Fahrenheit degree and want to know what it is in Celsius, use that formula. Okay? Okay. So this one asks whether or not it has an inverse, and if it does, find the inverse. 25 is out because it doesn't have an inverse. Remember, the parabolas don't have inverses. The only one I want to do is 22. And then we're done. You'll turn this in. Okay. So for 22, let's practice one more time finding the inverse. It does have an inverse. If you were to check the picture, it's our cubic function scooched to the right too. Okay. So all you're going to do is rewrite it in y notation. We're going to flip-flop the x and the y. We're going to flip-flop the x and the y. So wherever we see an x, we're going to put a y. Wherever we see a y, we're going to put an x. And then your job to find the inverse is to solve for the new y. So what gets rid of a cube? What is the opposite of a cube? Well, what gets rid of yes, a square. If you're not sure what gets rid of a cube, go back and think. We usually pop real quickly that to get rid of a square, we square root. Well, to get rid of a cube, yes, we cube root. So we're going to cube root both sides. So we get the cubed root of x equals y minus 2. Because the cube and the cube root cancel, it leaves us just what's inside. And how do we get rid of that minus 2 that's on the right? Yeah, we're just going to add 2. So our answer is that the cubed root of x plus 2, make sure it stays on the outside, it's not in that radical, equals y. We found it. That's our inverse. Now, let's put it in correct form. They say f of x, so let's call that f inverse of x, uses that little -1 notation, and that's the cubed root of x plus 2. Okay? So make sure you have this turned in. Please, please. And make sure you've turned in your 1-7 homework. The review stuff we did on the Monday, we didn't really do anything that's of any significance, but that's it. Now we're going to practice when we get back from Thanksgiving. We'll practice what's going to be on the chapter test, because the chapter test covers all of this stuff. Okay, everybody good?